Hey guys, so we're going to do 3.1 and 3.2. This is for our lesson 7. So we're going to graph sine and cosine, and I'm hoping a little bit of this seems familiar from last year, but we'll see how it goes, because specifically we're going to do this based on transformations. Your teacher last year might have had a couple of other ways to do it, but we're going to do it totally by transformations, because we are going to be doing our horizontal stretch and shrink, where some secondary 3 teachers do not teach that for now, but we're going to do everything. So an equation of the form y equals a sine b parentheses x minus c plus d with a not equal to 0 and b not equal to 0 is a sine function. It's a graph called a sine wave or a sinusoidal wave, sinusoid, anything like that. It's just a sine graph. So what we're going to look at is we're going to look at our parent function and always start with the parent function and then transform it depending on what's going on with it. Now, notice that the x represents the angle and y represents the sine value of the angle. And we can relate this back to our unit circle stuff and our coterminals. So that's what we're going to keep in mind when it comes to our parent function. Now, we know that in a unit circle, we can go around and around and around. So our graph starts to repeat itself every cycle. Well, the periodic function, of course, the period that we think of is 2 pi. That's one rotation, right? 0 to 2 pi is one rotation. So that's where we're going to start. But be very careful, because lots of these times the graphs want 2 periods when you graph, not just one. So you're doing 2 rotations. Now, the graph of y equals sine x over an interval of length 2 pi is called a cycle. So what happens within 2 pi? If it goes around twice, like if our sine graph does our period, well, not period, but it goes around twice, that means it happens twice in a cycle. Okay, so we need to remember that a cycle is what happens, how many times it repeats itself between 0 and 2 pi. And the thing to think about it, that in our parent function, the period is 2 pi. Now that can stretch to where it repeats. Okay, so let's think about our unit circle here. Sine of x. So at 0, sine is 0. At pi over 2, sine is 1. At pi, sine is 0. At 3 pi over 2, sine is -1. And 2 pi is back at 0. Okay, so now we're going to plot these points and see what happens. So at 0 is 0. At pi over 2, it's 1. Pi is 0. 3 pi over 2 is -1. And 2 pi is 0. And if we put this all together, we see this wave. And of course, this wave keeps repeating itself over and over. Now, hopefully this looks familiar, right? It looks familiar because sine starts at what we call the midline, okay? And it goes up for a positive sign. Last year, we learned that when it was a negative sign, it would go down and up. So let's look at some key features. Well, in this case, our period goes from 0 to 2 pi. So our period's 2 pi. Our domain, well, think of the domain of sine. So period was when does it start repeating itself? Okay, so of course that's 2 pi. Every 2 pi, it starts a new repetition, I guess we should say. But domain, if you think about it, because this is only a piece of our function, our domain goes from -infinity to infinity because it continues on forever. Now, is it even or odd? So remember, evens, you're able to fold it on the y-axis and it mirrors each other. Or odd is where it rotates around the center. So let's imagine if this kept going, right? That that wave. Okay, there we go. Sorry, my mind's blanking right now. Is this going to reflect across the Y or rotate around the origin? It's going to rotate around the origin, so it's an odd function. Now, amplitude. Amplitude is our distance or our height, as I refer to it, between our midline and our range, high value and low value. Okay. The other thing you can do is think about, it's just that distance from the middle. So right here, this is the midline, right? Right where we can cut it in half, and the distance is 1 either side. Now, a lot of people will say that it's the absolute value because we are talking about distance. So our amplitude is 1. And we just talked about our range. Our range goes from the lowest Y value, which in this case is 1, to the highest value, which is 1. Oh, lowest value, -1, highest value, 1. The graph of cosine has the same shape as the graph of sine, but it's shifted to the left by a distance of pi over 2. For this reason, the graph of y equals cosine is also called a sine wave. So the graph of y equals cosine x over 0 to 2 pi is called the fundamental cycle of y equals cosine. So we're going to do this again, set this up. So think of your unit circle, right? Cosine at 0 is 1. Cosine of pi over 2 is 0. Cosine of pi is -1. Cosine of 3 pi over 2 is 0. And cosine of 2 pi is 1. So now when we graph this, at 0 it's 1. At pi over 2 it's 0. At pi it's -1. 3 pi over 2 is 0. And pi over 2. And then all of a sudden it would start repeating itself, right? So this is a full period. And hopefully this looks familiar from last year, right? Cosine always starts at 1. If it were negative, it would start at -1 because we flip it, right? And it's kind of this valley. So our period is still 2 pi. Our domain is -infinity to infinity. But if we look and we continued this, is it still rotating around the origin? No, it's reflecting across the y-axis, which is an even function. Amplitude, okay, here's the middle right here, and it's 1 away. So the height is 1, and the range is still -1 to 1. Okay, what I'm going to do, and I'm going to prepare you for this right now, to save time, because I have tons of examples of how to explore what parts of the function affects what on the graph. We're going to look at the transformation specifically, but when it comes to graphing, I'm going to get the graph out ahead of time, and so I don't waste time with that, okay? So the amplitude, so let's go back to the amplitude. The amplitude we get from the coefficient in front of our trig function, okay? It's that coefficient in front. But because amplitude is height, it's a distance. I would never say I'm a -2 feet, right? So it's the absolute value. And see, they use it height too. So what we're going to do right now is we're going to graph 2 periods of the function and state the amplitude, identifying the max and min values of the corresponding. So I'm going to do this with you. We're going to start with our parent function, which since it's sine, we're going 0, pi over 2, pi, 3 pi over 2, and 2 pi. Okay, and sine, remember if we go back to our sine table, it's 0, 1, 0, -1, 0. Now we already know just from the function itself that the amplitude is going to be 3. But to find the range, we're going to have to look at the table value first. So think of our transformations. This is on the outside, so we do it to the y value, and we're multiplying by 3. So I'm going to multiply all the terms for the y value by 3. So I get 0, 3, 0, negative 3, 0, which means my range goes from negative 3 to 3. And now I'm going to make my graph and use my coordinates 0, 0, pi over 2, 3, pi over 0, 3 pi over 2, negative 3, so on and so forth. So remember, I did the transformation with you. Now I'm showing you the graph. So right here would be 1 period. So as you can see, I graphed 2. I kept going because our x values didn't change in distance apart. Okay. All right. So really, what did the amplitude do? Well, or that 3 out front do? It stretched the distance between the midline and the amplitude. Let's see what happens with our next one. Again, I'm going to state that my amplitude, don't forget that the amplitude is the absolute value. So I'm not going to say it's -5. I'm going to say it's 5. Range, we're going to have to wait until we see what happens in our table. So x, y, 0, pi over 2, pi, 3 pi over 2, and 2 pi. Okay, for cosine, make sure you get the table right, or the parent function right, because this is cosine, so it's 1, 0, -1, 0, 1. We're multiplying the outside there, so we're multiplying by -5. So we get -5, 0, 5, 0, -5. Now, if you remember things from last year, or even at the in 1050, that a negative out front means that we're going to flip it. We're going to reflect it across the x-axis. So let's look at what that looks like. Okay, so if I start plotting my points of 0, -5, pi over 2, 0, so on and so forth, here is my period. That's the first period, and then I do it for my second because it wants us to graph 2 periods. And look, it did flip. Remember, our original cosine, our parent function cosine, starts above here and dips down, and we reflect it because there's a negative out front. All right, the effect of C. What's going on with C? Well, this is on the inside, right? So that's what we call a phase shift. And we have to remember, just from 1050 and our transformation rules, that you always do what's the opposite of what you see, right? So here in these examples, we're going to do 2 full periods again. We're going to state the amplitude. So in A, our amplitude, that constant out front is 1, coefficient on constant. Phase shift. Okay, well, the phase shift, remember it's opposite, which means I'm going to the right, pi over 4. And then we're going to do the range here. Okay, oh, I forgot the range above, right? The range here was -5 to 5. Okay, but we need to do the table for this one to check out what happens. So x, y, start with our parent function. So 0, pi over 2, pi, 3 pi over 4. Why did I say 4? 2, and 2 pi. This is cosine. Got to check that trig function. So I know it goes 1, 0, -1, 0, 1. Now let's remember some rules from transformations, right? It's on the inside, so we have to do to what value? We do it to the x value, and we do the opposite to what we see. So we're not going to subtract pi over 4. We're going to add pi over 4 to the x. Okay, so this is where it gets tricky because you're doing your fractions, okay? Just keep in mind you can always do some side work if you need to. So, of course, 0 plus pi over 4 is pi over 4. Pi over 2 plus pi over 4. Well, 4 pi over, let's see, hold on. multiplied by 2. So it would be 2 pi over 4. 2 pi over 4 plus pi over 4 is 3 pi over 4. So got to add those fractions. Pi over 4 plus pi is 5 pi over 4. And guys, you see the pattern now? I'm actually adding 2 pi here each time over the 4. So this would be 7 pi over 4. These are little tricks for you. 9 pi over 4. Again, otherwise, just remember when you add or subtract fractions, they need the common denominator. Okay, we don't have to do anything to y in this case. So that means our range is -1 to 1. Now let's look at what happens to our graph. If you look, we move everything. So we're starting our period at pi over 4, and we go to 9 pi over 4. And look, it is cosine. See that wave there? It starts on top, goes to the bottom, and we're all good. But we need 2 periods. So I'm going to continue going out with my radians. So 11 pi over 4, 13 pi over 4, and it gets that wave. All right, let's try the next one. So right here, amplitude is 2. And our phase shift, remember opposite, so it's going to go left, pi over 3. Let's wait for our range until we see our table. So let's see, 0, pi over 2, pi, 3 pi over 2, 2 pi. Remember, you're doing sine, so it's going 0, 1, 0, -1, 0. So here you got to make sure you're doing both things. So the 2 right here is on the outside, so we're doing it to the y, so times 2. So 0, 2, 0, -2, 0, which of course I can get my range right from there, guys, right? -2 to 2. And then we have to subtract pi over 3. Again, watch those fractions. 0 minus pi over 3. Well, that's kind of obvious, right? Negative pi over 3. But when I look at pi over 2 and pi over 3, so I'm going to do some side work right now and see if we can come up with a pattern. So I'm looking at pi over 2 minus pi over 3. The common denominator, of course, is 6. So we get 3 pi over 6 minus 2 pi over 6, which of course then gives us pi over 6. Okay, do it again. So I get 3 pi over 3 minus 1 pi over 3, which is 2 pi over 3. 3 pi over 2 minus pi over 3, when you do that fraction out, you get 7 pi over 6. Let's see, 2 pi, that would be 6 pi over 3, so 5 pi over 3. Okay, so remember when you plot your points, guys, you're plotting the outside here. And I'm going to show you what that looks like. All right, so we're starting at negative pi over 3. Oh, and it looks like my practice round, I did that wrong, right? Because look at these values. Those are sine, not cosine. So that means I have to redo this to get 0, 1, 0, 1, -1, 0. So the good thing is all my radians on my graph are correct, but my graph itself is wrong. This is what happens when you go too fast. So I'm going to erase this little curve. Now, how did I know I did something wrong? The good thing about my mistake here and how I can identify it, as you see before, my graph started up here. Where does sine always start? It starts in the middle, not the top. Okay, so that's how I knew I did something wrong. So negative pi over 3 0 is right here. Pi over 6 is at 2. Then we're at 0. We're at negative 2, 0. So this is one period right here. Now, what helped me with the next period to help me graph that out, guys, is that I changed everything into 6s and over 6, and then I was able to see the pattern. So right here, I get pi over 6 to 4 pi over 6 to 7 pi over 6 to 10 pi over 6. So what am I doing each time? Well, I see in the numerator, I'm adding 3 pi. So that's how I was able to get these values quicker. Okay, so let me continue. That means we have up 0, negative 2, and 0. There is our second period. Okay, kind of glad I made that mistake so I can show you. All right, next, what effect does the value of D have? Well, the D has a vertical switch. Okay, so shift. So what we're going to do is do exactly what happens at the very end, just like we did with our other transformations. So we want 2 full periods, amplitude, phase shift, vertical shift, and our range. Okay, so the amplitude, our coefficient on front is 1. Our phase shift, well, that's what happens on X on the inside, so there is none. And our vertical shift is saying +2, so that means up 2. Let's see if I can remember my parent function correctly. 0, pi over 2, pi, 3 pi over 2, 2 pi. Sine, so 0, 1, 0, negative 1, 0. Now, +2 is on the outside. That means I'm going to do to the y value, the output value. So I'm actually going to do what is told. So I'm going to add 2 to everything. Add 2, we get 1. Oops. Sorry, guys. Add 2 to 0, you get 2. So when we talk about range, our lowest value is 1. Our highest value is 3. And what's great is we don't have to worry about that phase shift. So now I'm able to graph. And as you can see, I started in the middle, which goes along with sine. And I moved the whole sine graph just up to. My period is right here, and there is my second period. All right, a lot more going on here, right? Amplitude is 3. Phase shift, remember opposite, so we're going to go right, pi over 6. And vertical shift, we're going to go down 1. Zero, pi over 2, pi, 3 pi over 2, 2 pi. Okay, so this is cosine, so 1, 0, negative 1, 0, 1. All right, so as you guys can see here, the 3 we do to y, the minus pi over 6 goes to x, and the minus 1 goes to y. always do it in the order from left to right when you're doing it to the same side. So why the output, we're doing two things to it. So make sure you go left to right. So I'm going to multiply by 3 for the y's. And then I do exactly what's being told to me there with the subtracting 1. So 2, -1, -4, -1, and 2. So we go from -4 to 2. And then for our x values, remember we have to do what's opposite, so we're adding pi over 6. So we can get pi over 6. Again, when you do your fractions, we get 2 pi over 3, 7 pi over 6, 5 pi over 3, and 13 pi over 6. Again, all I am doing on the side right there is saying, hey, pi over 2 plus pi over 6, common denominators, and reduce. When I graph that, again, I'm starting at pi over 6, and my full period there goes to 13 pi over 6. So there's my second. This makes sense because cosine starts on top, and I plot my points. All right, let's talk about that period and talking about that squeeze, that horizontal squeeze or stretch. And that's what's happening with the period, and that has to deal with the b value, the coefficient in front of x. The period comes from 2 pi divided by the value of b. This means that there are b cycles every 2 pi units, which actually we also talk about frequency, which is defined by our periods. It's saying how many cycles are happening every second. Now, does it always measure in seconds? No, but that's what we're going to keep it as. The great thing is that we can find the frequency out by just saying 1 over p, which really what that does is it flips that 2 pi over b to b over 2 pi. So now we're going to graph the two periods. We're going to find what the period is. So when we find the period, we take 2 pi and divide it by the coefficient in front of x, which in this case is 2. So pi. Now, really, what does that mean? Well, if we go back to our original graph of sine, because we're doing sine here first, it means we're going to take this whole period here and actually squeeze this whole rotation into this little spot. That's what it means. We're taking this whole rotation and squeezing it so it actually does a full rotation in pi. Well, frequency, remember all we need to do is flip our period, so 1 over pi. And now let's do our table. 0 pi over 2 pi, 3 pi over 2, 2 pi. All right, sine, so 0, 1, 0, -1, 0. This is on the inside, right? So when we talk about transformations and with the table, on the inside we do to x, but we always do the opposite to what we think of. Now, it's multiplying by 2, so the opposite of that would be dividing by 2. Technically, multiplying by 1/2. So 0, pi over 4, pi over 2, and let's see what there, 3 pi over 4, and pi, which makes sense because didn't we get our period of pi? And what do you know? There it is, because remember this was a full period before, but now we're squeezing it. All right, so when we graph that, because our range now is still -1 to 1, because we didn't change the y value. And now we see that our full period is at pi, and I'm going to make 2 of them. So even though the way I graph it right now doesn't look like we actually squeezed it, right? Well, before, remember when I was making our graphs, I was saying that this is 2 pi, but it's not anymore. So in our 2 pi before, in our parent function, we had 1 cycle, right? But if you look, here's our 2 pi now. How many cycles did we go through? We went through 2 of them. All right, let's do another one, and then we're going to put it all together. So we have our period, which is 2 pi over b. Now in this case, guys, be careful because b is actually 1/2. Okay. Then we know that this is going to be 4 pi. Okay, so that 1 cycle is actually going to be stretched out to 4 pi. Frequency is then going to be 1/4 pi. Our range, we'll find out what happens in a minute. X, Y, 0, pi over 2, pi, 3 pi over 2, and 2 pi. So this is cosine, so 1, 0, -1, 0, 1. Only thing we got going on here, right, is what we're going to change for x. So this is multiplying by 1/2. So the opposite would be dividing by 1/2, which actually is multiplying by 2. So we get 0, pi, 2 pi, 3 pi, and what do you know? There is our period of 4 pi. Great. Now let's look at that, and there is our graph. So 1 period right here, and then I double it to get my 8 pi from the 2 periods. Now let's put it all together. What happens when we have to do all of our transformations? Okay, and we're going to do this a couple times, so you can speed through this if you want to, and just keep in mind there's a little trick with each problem. So let me identify each thing first. So the amplitude, remember, is what? It's the constant in front of the whole function, which in this case is 1. Our period is 2 pi over b, 2 pi over, and our b in this case is 1/2. So that gives us 4 pi. We learned that in the last example. Our frequency is 1/4 pi. Our phase shift, remember, what's added or subtracted to x, and it's the opposite. So this is minus pi over 3. So we're going right pi over 3. And our vertical shift, we're going to go up 1. So we're going to make the table together, and then we're going to identify our min and max y values, and I'm going to show you the graph. So x is 0, pi over 2, pi, 3 pi over 2, and 2 pi. We're dealing with signs, so we go 0, 1, 0, -1, 0. Okay, let's do the y stuff first because it's easier. We're multiplying by 1, right? So that doesn't do anything. And then we're going to add 1 to the y value, that output. So 1, 2, 0, 1, 2, 1. 1, 0, 1. So that tells me right now that the range goes from 0 to 2. So that's nice. Now on the inside here, remember we're going left to right. So we're going to multiply by 1/2 first. So 0, pi over 4. Oh, what did I do wrong? Forgot. I have to do the opposite. So we're not multiplying by 1/2. We're multiplying by 2. Now, how did I know I made that mistake before I made it, or before I started erasing? It's because, remember, at the end of this grouping should equal to our period. Okay, so 0, pi, 2 pi, 3 pi, 4 pi. And what do you know? There is our period. Okay, so now we do the opposite. So we're going to add pi thirds to each of our values. So we get pi over 3, 4 pi over 3, 7 pi over 3. You guys see the pattern already? We're going to add 3 to the pi's here. So that would be 10 pi over 3. And 13 pi over 3. All right, let's look how that graph looks. Starts at pi over 3. And then where is our cycle? And right over here, our period. And we're doing 2 rotations. Awesome. Okay, let's see if we can find a couple tricks, because what I want you guys to notice here is this looks like the beginning of our notes where we have our A, B, parentheses, X plus or minus C, and then plus or minus D at the end, right? Because if you look at example B, and this is very important, what's wrong with this problem? We don't have those parentheses, so we actually have to factor this 2 out. When we factored this 2 out, remember that we're dividing everything by what we're factoring out, leaving us x plus pi divided by 2, or pi halves divided by 2, is pi over 4. Now, sometimes what I do, guys, to check myself is I do that distributing really quickly to see if that's what I come out with, because this might be and this might C. So our amplitude is 2, period. So that's 2 pi divided by 2, which is pi. Frequency, which is 1 over pi. All right, let's do phase shift. So remember, though, with phase shift, we're looking down here. And we go opposite to what we see. So it's going left pi, over 4. And a vertical shift of down 2. Do our range here in a minute. All right, ready? Get your table all set up. X, Y, so 0, pi over 2, pi, 3 pi over 2, 2 pi. This is cosine, so 1, 0, negative 1, 0, 1. Okay, I'm going to do my output first because those are easier to me. So I'm going to multiply by 2 and then subtract 2. So multiply by 2, 2, 0, negative 2, 0, 2. Now I'm going to subtract 2. So 0, negative 2, negative 4, negative 2, 0. So what's my range? Lowest value is negative 4. Highest value is 0. Okay, remember to do opposite. So I'm going to multiply by 1/2. right? Because that's multiplying by 2. So I'm going to multiply by 1/2. 0 pi over 4 pi over 2, 3 pi over 4, and pi. And what do you know? That's my period, right? That's what I got over there. And then plus pi halves. Well, that means I've got to subtract pi halves. So negative pi over 2. Oh, not pi over 2. Look what I made a mistake, guys. I have to go back to that factored form. So I'm not subtracting pi over 2. I'm subtracting pi over 4. Common mistake. So 0. Then when I do this, I get pi over 4, pi over 2, and 3 pi over 4. Again, subtracting those fractions if you need it. And what do you know? There's our graph. And did it shift down and to the left? Yep, my starting is on the left side. And my full period is right here. Of course, I spaced this out too much, huh? And it is cosine. It starts on top, and we wave through it. All right, down below. As you can see, it's already factored, so that's great. Let's talk about our amplitude. Remember, amplitude is absolute value, so our amplitude is 3. So what we're going to look at here is that flipping. So period. It's already factored, so we're going to do 2 pi over 3, which means our frequency is 3 over 2 pi. Our phase shift, remember, do opposite, so that means it's going to the right 2 pi over 3. And our vertical shift of down 1. Now again, because that negative is out front, guys, we should see that our cosine is flipped. So instead of starting above, it's going to start at the min. So if you think you have this down, why don't you pause the video, because I'm going to show you the answer right now so you can see how you did the table without my help. So what we get for an answer is we're going to multiply it by -3 and then subtract 1. So we get -4, -1, 2, -1, -4. Our range goes from -4 to 2. Okay. Remember, this is multiplying by 3 on the inside, so we have to multiply by 1/3. Okay. 0, pi over 6, pi over 3, pi over 2, and 2 pi over 3. And what do you know? That is our period. It's good. We're going to do the opposite, so we're going to add 2 pi over 3. And as you can see, while I was doing my work, I did some side work of my fractions, common denominator, make sure it's all there. And then I see that I went to the right as I started, which is great because that's what I said, right. And my full period was at 2 pi over 3. Where am I? Oh, no, my ending spot is 4 pi over 3 right here. Look, it flipped. That's great. Now, to continue, what I did is I put everything into sixes, and then I saw a pattern. I'm like, oh, look, I'm adding 1 each time. And that's how I was able to get that second part. Okay, this is another one. We're going to practice that factoring. Okay. So pi over 2. When I divide by pi over 2, I get x plus 3. That is okay. What that means is that our radians are not really in pi anymore. They are in pi, but they're not using the symbol. The pi's canceled, or the equal pi over pi is 1, right? So you'll just see that it looks like our our horizontal axis doesn't have radians, but it is in radians. Okay, so we get the amplitude of 4 period, well, 2 pi all over pi over 2 gives us, and I'll write that down so you can see it, 2 pi over 2. When we divide by a fraction, it's the same thing as multiplying by its reciprocals. We get 4 pi, or not 4 pi, it's 4. Because the pi's kind of cancel out. That pi over pi is 1. Frequency, 1 over 4. Okay, let's see what else we have. We have phase shift. Phase shift is left 3. Vertical shift. Do we have a vertical shift? Nope. Nothing is added or subtracted at the very end. And then we need our range. All right, see if you can do the table again by yourself. Pause the video, fill it out. All right, so we have our table. Luckily for the output, we just have to multiply it by 4, which gives us the range of -4 to 4. Now here, you remember now we have to do the opposite. So we're not multiplying by pi over 2, we're multiplying by 2 over pi. So that cuts it down to 0, 1, 2, 3, and hey, what do you know? There's our period right there. Okay, and now we're going to subtract 3. Remember to look at your factor. Subtract 3. And what do you know? We went left 3. And we started in the middle because we're sine, so that's good. And then we went to 1. And we started our second rotation. Perfect. All right, almost done, guys. Right. Determine the equation. So now we're going backwards. Okay, now there are multiple functions that you can make because really we're looking at one period and it could be set either way. And we can make it a cosine, we can make it a sine, depending on what part of the function we're looking at. So we're going to do both. Okay, right now we're going to make a cosine. So first, what I want you to see is that this is a full period. Well, this full period starts at -1 and goes to 5, which means our full period here is 6. Now, how does that help us? It helps us find the b value. If you remember, that means that 6 equals 2 pi over b, and we can solve. This indicates that b is pi over 3. That's a good start, right? So now let's actually start putting this together. So we have f of x equals, we don't know if we're multiplying something up front yet. We're doing cosine. And we know that our b value is pi over 3. Okay. So that's what we have so far. Now let's see what we can do next. Let's talk about the vertical shift. The vertical shift is talking about how much it went up or down. And we really can look at this by looking at the midline. If you look at the midline, would have been for a parent function at 0, but now it's at 1/2. So that vertical shift there is 1/2. And it went up. So what does up 1/2 mean? It means we add 1/2 at the end. All right, let's talk about phase shift, right? Actually, let's go amplitude from here because the amplitude's easier after pointing out that midline. That midline says we go from 1/2 to 5/2. So we went up how many things? 1, 2. That height right there between 5/2 and 1/2 is 4/2, which is 2. Where does the amplitude go? Goes right in front of that coefficient. As that coefficient. Phase shift. Okay, this is cosine. Cosine starts top and on the y and the at the y-axis, right? Usually it starts here. So it went to the left, and it went left how many? It went to the left by 1. So left by 1 would be adding 1. Now, yes, there could be multiple versions of this equation, but I want to show you too that if we were to need this other parenthesis in there, if we needed to distribute that out, that would be correct also. Okay, so now we're going to do the same graph, but we're going to do it with sine. Okay, so what I want to show you is that, remember the graph did this, right? Well, a sine graph starts in the midline, and then why not keep it, like we could start at this midline, but it would then go down, so it would be negative sine. But I want to stick with a positive sign right now. So if I look at the graph on the other page, the midline going up is right here. What coordinate is that? That is 7/2, 1/2. Now, the great thing about us already doing the cosine version is the amplitude, the vertical shift, and the period are still the same. So right now we have f of x equals, the amplitude was 2. Now we're doing sine. That period was pi over 3. And our vertical shift was up 1/2. So the only thing we're missing is that phase shift. Well, usually we start at 0. So that means we moved to the right 7/2. What does right tell us to do? It tells us to subtract 7/2. Make sure I marked it. Yep. All right. What if we get a story problem? What are we going to do here? Let's read this. A circle with radius 3 feet is mounted with a center 4 feet from the ground. So the center is 4 feet from the ground. The point closest to the ground is labeled P, as shown below. Sketch a graph of the height above the ground of the point that it's rotated. Find a function h that gives the height in terms of x. All right, so if we were going to start with a graph here, we see that we are 4 feet from the ground is that middle, is that midpoint. So 4 is the middle of that graph. And from that middle, going up and down is how long? It is 3 feet. So that's the highest. 3. That's the lowest. Okay. So, of course, P is starting below. So we're starting at the ground below, and then we're doing our wave. What does this look like? It looks like a cosine, but specifically it's a negative because it starts below. So as you can see here, our vertical shift is 4. Our amplitude is 3. And we're talking about rotating a 1 cycle in 1 period, so we don't have to worry about the rest. What we do know is that h of x now is negative because we start below. Amplitude's next, 3, and it starts below, so it's cosine of x, and that vertical shift was at 4, and we're done. One more example, no drawing here, so you might want to draw it yourself. The London Eye is a huge Ferris wheel with a diameter of 135 meters. It completes 1 rotation every 30 minutes. riders board it should be from that form, a platform of 2 meters above the ground. Express a rider's height above the ground as a function of time in minutes. Okay, so we have this Ferris wheel. Of course, where does a person get on? A person gets on right here. And this is 2 meters above the ground. Our diameter is at 135. So if we're talking about the middle, just like on our other problem, this would be 67.5. Okay, we know our period is 30 minutes. So we have to solve, right? So we have 30 equals 2 pi over b. So b equals pi over 15. Now let's talk about some things that we see here. Amplitude. Amplitude, of course, is from the midline to the top or the bottom. So in this case, it's 67.5. Where is that 2 going to come into play? Well, it comes into play with the vertical shift, right? We're not just stationed at that midline there is not stationed at the ground, right? Stationed in the middle. Well, what's the distance from the ground to the middle? 69.5. And of course, just like in our other problem, when we write a Ferris wheel, we always start at the bottom, which would be a negative cosine. So now when we make our equation, we have our amplitude of 67.5, but it's a negative cosine because we start at the bottom. We have our period of pi over 15. And then x. We don't have a horizontal shift. Don't have to worry about that. But we do have a vertical shift of 69.5. We want to make sure that we're off the ground so we don't scrape that seat on the bottom of the ground. Imagine this is what they do all the time to figure out rides. Whew, that was a long lesson, guys. Enjoy practicing these. Be careful on your graphing on the computer. Play with it a little bit, get used to it so you can take your quiz.